Howdy, my name's John Goodling, and this is episode 3 of my boat project with my brother. So, this episode, we're going to be talking about the engine. So, this is essentially what we got. My dad had bought this a long time ago, and it was sitting in a warehouse for a long time. This is an LM7 out of a 2003 Chevy Tahoe with a 706 heads. It's a 5.3 liter engine. It's part of the LS series, and it was pretty beat up. We think it probably had 150, 200,000 miles on it pretty easy. And we just loaded it up in the back of the truck and took it home. So this is what it looked like when we took the main caps off, pulled the uh, crankshaft and the camshaft out. The camshaft was stock OEM, so pretty low power. I think they produce like 200 horsepower stock from the factory. I know some people get a lot more out of them, but that's, or no, it's 300 horsepower from the factory. And then it had spun a bearing. This crankshaft was pretty beat up, so it wouldn't have run if we had just put it together and tried. So we rebuilt the engine, and the first thing we did was put it up on an engine stand, and we sanded all the surfaces flat with a piece of glass and some sandpaper. We also honed the bore. We didn't do any, we just resurfaced them. We didn't take off too much material. We bought all new bearings and put new piston rings in it. So we got a new oil pump for it, a new harmonic balancer. We had a aftermarket resurfaced crankshaft, and you can see we cleaned up the headers pretty good, and we lapped the valves in, which probably changed the tolerances, but it didn't. It doesn't affect it. We've run this engine, as you'll see. But we cleaned up the engine pretty good, and that's Will putting it back together. We have the water pump on there. We put the heads on. Uh, we bent some of the old lifter rods, so we bought some new ones, and we ended up buying new springs because these started to crack. We ended up going with a stage 2 camshaft with 0.585 inches of lift and a different cam duration. I think it was 112-degree cam duration. So it's pretty stout compared to what it was originally. We were hoping to get about 400 to 450 horsepower out of this thing naturally aspirated. And then we also went with a dual plane intake because dual plane is supposedly better at low RPMs, uh, but we didn't have anything to compare that off of. We also went with an oversized Edelbrock carburetor. This one is the 1405 Edelbrock. It's rated 600 CFM, and it's a little bit bigger than what we needed. This should be able to support like a 6.0 engine pretty easily, so a 5.3 it would do fine with. And the reason we went with the carburetor rather than the stock port injection or direct injection or carb injection is because this can be actuated almost entirely with it uses cable systems, and we know they're reliable, and we wanted to learn how a carburetor works and how to tune them. So we put this all together and we sent it out the door. We had a bit of trouble transferring it from the engine mount to the engine lift, but we eventually got it through this doorway and we mounted it into place. So you can see the engine mounts along the bottom of the hull, which go from the transom all the way forward, and it uses stock LS engine mount. So you could pull these two pins out and lift the whole thing up, and there was quite a bit of lifting this thing up and taking it off to re-weld, and we re-welded the inside. We moved things around, and it took quite a bit of adjustment because of this U-joint that attaches the jet pump to the engine. It wants to be as straight as it can be. It has a little bit of play, but you want these to be on the same. You want the face. You want them to be axially aligned and linearly aligned. So uh, it took quite a while. We probably spent a day getting all of this stuff aligned, and then after that we noticed that it had quite a bit of wobble to the left and to the right. So we welded in some gussets to the side to prevent the engine mount from rocking back and forth. Now, this strengthened up the back end of the hull quite a bit, and it made the engine rock solid. It's mounted directly on. There's basically no vibrational bushings, but the engine is fairly well balanced, so it doesn't vibrate the rest of the boat. And from this point on, it's just welding in parts. And again, what you can see, we took the engine back out, welded a nasty bead along the bottom, but it holds a fuel. And what we ended up doing is, with this space, we figured that would make a great fuel tank. It's probably not the best way we could have done it, but it allows us to carry 28 gallons of fuel, and it's right there next to the engine, and we don't have anything sloshing around. And all we ended up doing was drilling a hole along on the bottom of each of these and connecting them with a pipe, and then with a T-fitting it goes up into the engine. So there it is with the engine mounted, and Will's having a good time welding back there. You can also see that we made a custom bracket so that we could mount the alternator a little bit lower, and it's just got a lot of little things that we added to it. Like the valve covers, we got nice spark plugs. We had to use an MSD for the spark timing because we couldn't use the stock computer for this engine. And the rules require that the back or the top half of the flywheel uh, be covered. It's fairly dangerous to have a geared spinning thing in a boat, especially considering how much we ended up crawling around in this thing when we got it running. So we made this plate that bolts in at 3 places and then welds to the fuel tanks. And it's a safety precaution, and it also prevented the engine from wobbling even more. Those 2 mounts made out of aluminum were fairly loose, and so now there's 5 big bolts holding the entire engine in place and mounting it solidly to the hull. And that's just Will showing off some of his welds. He got pretty good at it, and you can see some of the other ones that we did. And they don't look super pretty, but it's very difficult to get an aluminum weld to look very good, and they hold fuel, so that's what really matters. So if you'll notice back here, the stock exhausts, we mounted them upside down just to see how they would look. We probably could have used them, but they're all collector types. They're very short. It would probably rob some power because they're uneven length, and they push a lot of back pressure into the cylinder next to them, and they're pretty ugly. So we decided to go and make our own exhausts. So I ordered a flange offline, some stainless steel elbows, and some tubing. So this cost me about $200 to make both sides, and I ended up welding it with my TIG welder. So it's all airtight, and we ended up making zoomies. They look better than the stock, and they are really impressive to hear and see. And we figured any imperfections in the handcrafting of it wouldn't make a difference when it's doing, I don't know, 80 miles an hour. So it looks cool. It sounds cool. It's everything we could have wanted, and they've turned out really well. And that's what it looks like with both of them installed and the engine. Now, as soon as we got all this stuff done, we immediately wanted to start this. So we we basically started recording us attempting to get her started. We hooked up the MSD, we hooked up a fuel pump to it, we hooked up a battery that we had to jump off with a diesel truck, and let me see. So that was us starting it up, and you can see it popped and sputtered, and it was pretty loud, but it had a couple of problems, and we started to adjust some of the timing and the fuel pressure and the mixer valves in the carburetor to get it to run right. And this is the second attempt with that we actually recorded. This is the second attempt that sounded good. So you notice there were a couple of problems. I had to idle that very high on the carburetor just to keep it running, and the entire left bank wasn't firing. The exhaust tubes didn't get warm at all. So as it turned out, and we found this out after, I don't know, an hour of messing around, the entire harness for the left side was put on backwards for the spark plugs. So we swapped that around, and this was the very next startup, and it sounded great. But you can see I put on some hearing protection because this is very loud. And that's it. That was us starting up the engine, and that's basically how it sounds to this day. It's it was kind of a magical moment. That was a magical afternoon for us. But that's the end of episode 3. Thank you very much.